we'll start with those 25. While I work the problems, you can work the problems along with me. So I'll give you a chance before I give my answer to try to answer the question. The purpose is that the more problems you work, then the easier it's going to be dealing with the problems that you see in your courses. So without further delay, I will start. So it's 25 exponent problems. Okay. So the first problem I'll present is 1 to the power 0. 1 to the 0th power, right? So if it's 1 to the 0th power, what is that going to be equal to? 1 to the 0th power, of course, is going to be 1, because anything raised to the 0th power is 1. So problem number 2 then, how about 3.5 raised to the 0th power? It equals what? Okay, I'll give you a chance, and then it equals 1. So anything again raised to the 0th power is 1. Let's say we take a large number and we say, okay, how about 360 raised to the 0th power? What is that going to be equal to? Of course, the answer is also 1. And another problem on this matter, so problem number 4, if we have, say, 3x to the 65th power, all of that raised to exponent 0, what is that going to be? Okay, so once again the answer here is 1, and of course we could split it up as 3 to the 0th power times x to 65th power, all of that to the 0th power, which is 1 by 1. However way you want to put it, the answer is always going to be 1, as we raise all of that to 0. Now let's move on to some other type of problems. So example number 5, if we take 2 to the power to the first power, what is that going to be? And also you can pause the video if you want, but I'll give you a chance. Okay, the answer is 2 itself, the number itself. So another one, so question number 6, let's say we take 3 to the 3rd power, what is that going to be equal to? Okay, of course, by the law of exponents, we have 3 times 3 times 3, which is 1, 2, 3 times, and then 3 times 3 is 9, 9 times 3 is 27, so our answer here is going to be basically the answer is, I'm going to erase the question because I don't have room, but the answer is 3 to the cube equals 27. Okay, let's move on to problem 7. How about problem 7? Okay, just a moment here. One to the 10th power, what is that going to be equal to? So the answer to that is 1. Of course, if you multiply 1 by itself 10 times, you're just going to get 1, however many times you multiply it. Now, a problem similar to that is, let's say we take, this is problem 8. Let's say we take 1 to the 99th power, so we multiply it 99 times. What is that going to be equal to? Of course, the answer once again is 1, because we're multiplying 1 by itself so many times. So now problem number 9. Let's say 10 squared. What is that going to be equal to? Relatively easy problem, so depending on your experience and your exposure to these problems, the answer is 100, which is also the same thing as 10 times 10, right? 1 time, 2 times, corresponding to the exponent 2. Okay, that's problem number 9. Problem number 10. So let's say 10 cubed equals what? So of course it's 10 times 10 times 10, 1, 2, 3 times, corresponding to the exponent, and we have therefore 1000 as our solution. Okay, the answer is 1000. Okay, so moving on to problem 11. Let's say we have x cubed. What is that going to be? X times x times x times x. Eraser, okay. Having a difficulty with my eraser here. Won't be long. Okay, solve that. So times x, so it's the same thing as x cubed basically. It just means that you multiply it by itself 3 times. Okay, and then problem number 12. Problem number 12. Let's say, for instance, we have x y cubed. What is that going to be? So this is the same thing as saying x cubed times y cubed. That's the answer. Okay, so that's problem number 12. And then let's move on to some other problems. So problem 13. Let's say we have 0 that is raised to the first power. What is that going to be equal to? 0 raised to the first power. Of course, the answer to that is 0. Or put it in green. Now moving on to number 14. Let's say we have 0 to the third power. What is that going to be? Of course, the answer for that is 0, because this is the same thing as 0 times 0 times 0, 3 times, 1, 2, 3, comes down to being 0. Regardless how many times you multiply that 0 by itself, still yields 0. Of course, last problem to bring this point home, 0 to the 82nd, so you multiply it a bunch of times, the answer is going to be 0. Okay, that's problem 15. How about problem 16? Problem 16. Let's say we have x to the negative power 5. What is that going to be? So when we have a negative exponent, what is the meaning of that? So it's going to be equal to 1 over x to the 5th power. It's basically the reciprocal of x to the 5th power. So we have to divide because we have a negative power. or a negative exponent, if you wish. So number 17, say we have 10 to the negative 3. What is that going to be equal to? So same idea, the answer is 1 over 10 cubed, which actually works out, we can actually put it in decimal form, which is this answer here. Now pay attention to what your professor wants, how he or she wants the answer. Sometimes they want it in exponentiated form, sometimes they want it in a decimal form. It's their prerogative. Follow their instructions as to the problem statements. Now problem 18, let's say we have 4 to the negative 1 power. What is that going to be equal to? Of course it's 1 over 4 to the first power, which is basically 1 over 4, which is 0.25 in decimal form. Okay. Now problem 19, we have 5 to the negative 4th power, so of course that's going to be equal to 1 over 5 to the 4th power, which is 1 over 5 times 5 times 5 times 5. Okay. At any rate, it's going to be equal to 1 over 625, or 0.0016 is our answer. That was problem 19. And then problem 20. Okay, problem 20. If we have, now this is actually a negative, so we have negative 4 to the power minus 3. Okay, what does that equal to? So the way I do it, I just put my negative, nothing happens to that, and then I deal with the exponentiated number. So it's going to be 1 over 4 cubed, and then at that point it becomes negative 1 over 64, which is 4 cubed. The answer becomes a pretty long number, so it's negative 0.015 625, right? That's the answer to that problem. So the negative remains in this case. Okay. All right, we have 5 more problems to go for this particular video. So problem 21. So at that point, it's 10 y to the 7th power, and then w to the negative 10th power. What is that going to be equal to? So, or we want to rearrange it basically where all the powers are positive. Okay, how can we do that? So at any rate, we only have one power that's negative, right? So we've got to transform that into a positive power. That's pretty much it as our answer here. Okay, problem 21, and then 22. Let's say we have 3 to the 4th power multiplied by a, that's a as in alpha, to the 4th power, and then c as in Charlie to the 0th power. What is that going to, can we clean that up so that it's nicer? So at that point it becomes 3 to the 4th power times a to the 4th power, because in fact c to the 0th power is going to be 1, as we saw earlier. Therefore it doesn't need to be shown the answer, so the cleaned up answer is this. Okay, problem 22. So moving on to problem 23. The statement is a, as in alpha, to the -3 third power. Let's see here. Never mind. I have the wrong problem. We'll do that later on. Let's do for 23. What I actually had written is, let's say 4 to the 0th power times 5 to the 4th power times c to the 0th power. All of that divided by 2 to the -3. Okay, can we clean that up? And also make sure that all the exponents are positive. So, of course, 4 to the 0th power becomes 1. C to the 0th power becomes 1 for reasons that we gave earlier. And then it's going to be, we're left with 5 to the 4th power divided by 2 to the -3 power, third power. Okay, so now we still have a negative power. It turns out that once it's negative, since it's the reciprocal, the negative power is the reciprocal of the positive power, so we're going to end up with this as our solution, or a cleaned up version with only positive exponents. Now what's happening, the way I can explain this is, let's say you have 1 over 2 to the -3. So we know that this actually equals to 1 over 1 to the 2/3. And basically when you have something, when you're dividing by a fraction, you have to flip the fraction to find the answer. So it becomes 2 to the 3rd power, because this part here becomes flipped. So that's just a little background on dividing by a fraction. Okay, that's number 23. Let me erase that. Then number 24. Number 24, if we have 15 y to the 5th power, and that divided by x to the 4th power, and also w to the -5 power. So this situation with the negative power at the bottom is similar to that which we just saw in problem 23. So I'm going to do the same thing here. So the 15 y to the 5th power is fine. All powers are positive there, but the w to the -5 power, we're going to flip it as we did 2 to the -3 in the other problem. So it's going to be this, and then x to the 4th power, we cannot really make that better, so we keep that as is. This becomes our solution. So we're going to do our last problem here for this problem set, for these examples, 25 problems. So 25, let's say we have a, as in alpha, to the -3 power, b to the -4 power. What is that going to be? So this is a simpler problem than what we just saw. So it becomes a reciprocal, right? So it becomes 1 over a to the 3rd power, b to the 4th power, and this in fact becomes our answer. So thanks for watching this first video. As I said, I'll be doing more problems of this sort and maybe other things than exponents in the future. Don't forget to like and subscribe if this video was in fact helpful to you. Have a good day. Thanks.